So here what we have is we are giving this function and it says graph that function and then graph its derivative. Let's graph f of x first. This is will be a linear function in form of x mx plus b, where b is 0 and m is 5. So to have a positive slope and the y-intercept will be 0. Okay, this is 5 and that's f of x. Now to find its derivative, again, derivative is the slope, so we just say f of prime of x will be just 5, and then we can graph it as this is 5 and that will be the derivative. Or what we can use as our definition, our rules, which says, so what we notice here, f of x is increasing, but it's increasing at a constant slope. It's the same slope everywhere. So that means the derivative first will be positive since f of x is increasing, but it's increasing at a constant rate. That's why its derivative is a constant. This is the same equation as this in the top, but here the function is cosine of x. We'll graph this, and then we want to draw the graph its derivative. First, let's derive the function. Start from 1, so it's gonna be something like this. Okay, and we'll be oscillating. This is 1, this is minus 1. Now let's graph its derivative. So first, let's take these points, peaks and bottoms. Let's project them down into the derivative. So if you notice here, if we draw the tangent line, which is the slope of the curve at this point, it's gonna be 0. This is the same thing as saying that the derivative here will be 0 at these peaks and bottoms. So at this point, at the f of prime of x graph, they gonna intersect with the x-axis. Now let's take segments. So let's notice this segment here, from here to here. This is f of x again, but this is decreasing, okay? What does that tell us? It tells us that f prime of x will be negative. But we can also notice here, at this point exactly, it's gonna be the steepest negative slope. So that will be the more negative point from here. So if we graph that, that's gonna be something like this, where this point will translate to this point, whereas here we draw the tangent line again. That's gonna be negative, but gonna be the steepest compared to this and this segment. And then from here to here, it's gonna be a positive, okay? But again, here the slope is the steepest, so the highest positive. So if we translate here, it's gonna be something like this. And then again, here we'll reach to a horizontal slope, which translates to derivative to be 0. And also, you can do the same thing to this part of cosine of x, But since this function is symmetric, what we can do is so here what we can do is this segment in here we can apply the same rules, but again remember you are always reading from right to left, not from left to right. So from here this point will be 0, and then here the value of f of x is the function is going down. Okay, what does that tell us about f prime of x? It tells us that the values are negative, so f prime will have negative values. But here this is the most negative point, so that will be something like this. And again here this is positive, since here the value of f of x is increasing. That tells us that the slope here, the f prime of x here is going to be positive. Okay, so it's gonna be something like this. And again at this point we will have the most steep positive, so that will be something like this. So if we extend this, it's gonna be something like that. And this looks very similar to sine function, but actually it's not. It's similar, but it's flipped. It's sine of x. So if f of x is cosine of x, its derivative will be minus sine of x. So we are giving this function in here. This is f of x. We are giving these points x1, x2, 3, 4, 5, and 6. And we are asked to find these values where f of x greatest and lowest, and where is f prime of x as greatest and lowest. Let's find these two, since this is easy, since we are giving f of x. F of greatest will be the positive highest value, so that will be, let's see, this will be x of 3, since it's the highest value in here. Lowest will be the most negative value. At this point will be x1, and then f prime of x greatest will be where we have the steepest positive slope. So we have a slope here positive, so at this segment here we have positive slope, and at this segment we have a positive slope. But we can find here, this is where is the steepest. At x5 we have the steepest positive slope, so x5 will be the greatest, and the lowest where we will have the most negative slope. So where we have negative slope here, we'll have it at this segment. This is the only actually segment we will have it. So here at x3 we notice that this is negative slope, and this is the only negative slope, therefore it's only gonna be x3.